Yes, we are live. Hello, everyone. Welcome to today's session. My name is Mustafa, and our presentation for today is with Talabi Opemipo. Uh, Hello, Chief. What's
Hello.
up?
Hello.
Hi. Welcome to today's session.
Thanks for having
Hello,
me.
Yinka. Yinka is in the chat section. Yes, we are starting immediately, and people will join in as they want, right? You're welcome to start with us. All right. Hello, Ben. You can introduce yourself so let people get to meet you.
Okay. Thanks again for this opportunity. I really appreciate. Hi guys. My name is Talabi Opemipo. Software engineer. Most of my experience have been in the fintech space. So I work in the capital market space. Then moving on to um, payment processing, and then I'm back in the capital market space at Zcrest Capital. Then I'm also at engineering manager at iBlue Events. So yes, that's that about myself so far.
Thank you very much. It's nice to have you here.
Thank
So
you.
let's get right to it. We are going to be learning about integration testing with Docker.
Yes.
What is it all about? You have the floor.
Okay. The topic integration testing with Docker is the topic I've selected to speak on because as software engineers, we write a lot of tests, automated tests, to ensure that can guarantee that we what is expected of the business logic we write or the applications we write meets the expectations, right? So for integration testing with Docker, I'm going to start introducing the topic integration test. So on this slide, I say integration test is the approach where you go beyond the units. So we are in the cadre of automation tests. We have unit tests, we have integration tests, and we have end-to-end tests. So when you are testing the business logic as a unit within itself, right, without any dependencies, then it says a unit test. Then when you start introducing dependencies to it, then it becomes integration test. And then we have other ones like end-to-end test where you test all from beginning, as the word implies, end to end. So but for integration tests now, yeah, remember we are introducing dependencies, right? So you're testing your app as a component. That's your app and your dependency in this case. So if you look at this diagram, we have the app and the database that form a component, the app and the queue that form another component, or it can be your app and another app that forms a component. So those are the dependencies, right? When we talk about integration test. They're valuable because they mimic runtime behaviors, right? So you know that when your application is talking to your database, which is your production database in this case. Now, when you're testing, you want to ensure that your app also works in a near real time scenario, whereby real life scenario rather. So that's integration test. So then, which how does Docker fit into this topic? So with respect to the topic, we're exploring how Docker comes in handy to integration testing, right? So yeah, Docker. I said in this slide that Docker provides accelerated. I don't know if anybody by show of hands in the comments familiar with Docker, right? Okay, okay. Yes. So we're familiar with Docker, right? Docker offers containerization for applications and or yeah, applications. That's the right word to use. Be it your own application or other people's application. Docker provides containerization efforts for it. So then, how does it fit? Docker fits into this topic because it means that you can containerize your test dependencies to work with the components within your app. So so today, for the scope of this presentation, we are going to be focused on test containers. So test containers is a library that provides lightweight API bootstrapping with real-time service wrapped in Docker containers. So what does this mean? It means that it's a library that is built on top of Docker that allows you to bootstrap dependencies quickly using your Docker daemon to to expose these dependencies to your test. Then, so what does this mean? What does test containers offer? So, traditionally, what people do before now is that uh, people write scripts, right, to automatically generate containers. Once you generate the containers, then you ensure that you there's a tear down in your containerization efforts, right? Then your app, you run your test. So after your test, you tear it down. So, but what test container does is that it makes it a lot easier, right, to be able to spin up these dependencies. So if you look at what I wrote about this, the benefits of test containers, I said no more long running dependencies where you have a dedicated instance for running your automated test. So um, if you write libraries, for instance, or SDKs, for instance, now it means that for you to test the dependencies, that's say for instance your SDK interacts with a database in this case, right? You need to have like an instance of a database running somewhere that you can easily make all those DB calls to, right? Then in some other cases, where let's even go outside the scope of SDKs, it might be another app entirely, but you have to have a database instance running somewhere. But most of the times, these SDKs, these applications, and I'm very particular about SDKs because SDKs are usually um, short-lived developments, right? It's not every time you release a version for your SDK. You might release a version this month, then it takes you another 2 3 months before you touch the SDK. So those kind of things, it does not make any sense to keep long instance of all these application of your dependencies running just for the sake of that application in codes for your SDK or for your application development. So with test containers, you can easily spin up your your dependencies and run your test, then tear it down as soon as you are done running your test, and that's it. So then for data access layer integration tests, mocking DBs and in-memory databases are not close to system reality. So case in point here is when you are designing for, let's say, what an example that comes to mind here is testing for schema dependence, right? You are building an application on a relational database, right? There's no way you want to be able to test your relationships between different entities, right? So mocking and in-memory database have proven that they don't they don't cover those realities for your databases. I've used .NET in-memory data. .NET offers in-memory database for entity framework. Then other solutions like even in Node.js, there's all these other libraries that try to mimic the dependencies in this case, but they don't still give you real life scenario of how your app is going to um, behave uh, in these terms. So then I said no more excessive scripts for test dependency management. So traditionally, you write a lot of scripts to spin up these Docker instances or these containers. Then you also have to write another script, or you have to maintain those scripts to ensure that the teardown does not interact with does not affect the performance of your test, right? So then in this next slide, um, I'm presenting a code sample. I don't know if you can see my screen. I'm presenting a code sample, a use case where test containers, Mustafa. I don't know if you
Your
can
screen
still
is
see my
visible.
screen at this point.
Yeah, yeah, it's visible.
Okay, okay. You can see the lines of code. So this is like this part. I'm using Go for this presentation. This sample was written in Go, and I'm using test containers library. So then in this part, if you look at the lines from lines 35 of this code, right, this is a demo of using test containers to spin up generic this is a generic use case for test containers, right? So when I mean generic, it means that you can use this generic container request to spin up and to containerize any, like, seeing that Docker provides an avenue for you to containerize your applications or anything, that can be containerized actually. Yes, anything that can be containerized. So we have the generic container request that allows you to do that. So anything you want to containerize, you can put it in the generic request. That's on line 35. Then once we create the request, when we have like a we can now expose ports and the likes, then your container is actually up and running. That's at the test. So if you uh in testing, if you are writing test suites, right? I think in yeah, if you're writing test suites, you know there's a startup, there's a before. I think in Node.js is like a before, then after. So the test suite at the startup of your test or your setup of your test, this is usually where this comes in, where you have to create your containers. Then you can now run like your after your suite has been run, then you can now tear it down. So I'm going to be showing how to so in this line yeah, this particular line, so it's okay, let me go back. So this particular slide is showing how to create generic containers generic containers for your that represent the your dependencies now in this case. Then this particular slide, the next slide rather, is showing support for particular containers. So if you check the test containers website, right, there are also libraries that are particular to commonly used dependencies. For instance, in this case now, this is a particular Postgres container that has been provisioned for by the test containers library. So you see that instead of making a generic request, we are directly creating a Postgres container from on that's on lines 25. So showing this side by side because to show you guys the possibilities, right, of this use case. You can use for the generic. So let's say in-house you have an application, right, that you want to spin up as part of your dependencies. You can use, and it's not available, of course, because it's in-house, right? It's not commonly used by other developers. So you can use the generic container request to spin up that that dependency. Then you can use that one in-house. So then you can see this container request contains the name of the image of the container, then the environment variable, then we have the time waste strategy, right? So for the image, then that's the image of your dependency or your app that you want to that's the image of the app that you want to containerize, right, in this case. So then for the next slide now, this particular slide, we're showing you that this is going to spin up a particular is Postgres. So because these libraries supports other applications in this case, and this case is a Postgres container, right? So we don't need to make a generic request. So it comes inbox with the test container library. So then we spin up the container, we provide our image, we provide the database name, the username, password. Then we have the time waste strategy, where you want to the time waste strategy is basically a delay that you want your application to come up before the test container is ready. So then you return the so if you look at this code, I in my create Postgres container function, I'm creating the Postgres container. Then if there's any error, I'm returning the error on line 37. Then I also wait for extra 1 second in this case. Then I return the Postgres container that was created. Then that's it. Then in my test suite, so this is my test suite now. Uh, in my test suite, if you look at line 39 on my test suite, right? That's my setup test. So that's my setup test. So because I'm using a suite, right? I have a setup. I have a before, after it test case. Then I now have a tear down. So in my setup, that's where I actually create my dependencies, right? That's for because when you're writing automated tests, you want to ensure that each test file is isolated and that is independent of the other test files. So, how do I put this now? So if I have multiple test files in this directory, like customer underscore test, I might have other ones like customer underscore test two and the likes. But because this particular test is contains related use cases, that's why I'm using the particular suite to, have a setup. Then I'm using the what's the right word to use for this particular term? I'm using the setup suite for because the setup they are going to use the test case rather in this file are going to use the same setup. Yeah, that's the right way to put it. So I've created in my setup suite. I online 36. I make a call to my Postgres container. Then after creating it, then I return the details that I need. Then I set my database context based on uh, when the container is returned, because I need to know whether the container is up. So container being up in this case is basically my database being up, right? In this case, because I'm testing for a customer, I want to show my test case is on lines 25, where I want to test create customer, should return customer. So in my setup, I ensure that the database is up. Then once it's up, I return a connection string. Then I use my ORM, in this case, GOM, to to um, open a connection to my database running in the container at that point. Then I return a database context that I can. So my database context is what I can now reuse in my test use test cases in this case, because my of course my repository is going to use my database context which I've gotten from my test containers. So at the end of the day, at the end of my running my test case, I now have a teardown suite where I can now, like, drop the container automatically. So that means at the end of every test, at the end of the suite, the the container is deleted or destroyed in this case. Uh, yes. So I have references to this my talk. References are to the test containers documentation itself. Then, if you want access to the code, also this is a demo code base. Then, if you have pull requests, you can also pull up. Let us collaborate. Let us make the repo fun for other people and the learning. So there are a lot of other things you can learn from that repo. Uh, yes. So thank you. Stay curious.
Thank you very much for this wonderful presentation.
Thank you too.
Um, nice presentation. So I have some interesting questions. Um,
Okay.
if you're wondering why I'm looking at two places, it's because I have a second camera, a second screen. That's why.
even even myself, I'm presenting on this screen and I'm looking at the screen for the video.
Yeah. So my question is, based on your own experience, what do you think are like the best practice way to set up uh, this kind of environment?
I think I lost some words there. The best practice way
Uh,
to.
yeah, like if I want to set this up, what should I be noting and what should I be aware of?
Oh, okay. Okay. So firstly, you need to have Docker running on your machine, right? So because the test containers is built on top of Docker, it needs a Docker daemon to run. So once you have the Docker instance running on your machine, be it Docker desktop or the CLI, right? You are good to go with test containers. Then test containers support different programming languages. For this demo, I've chosen to their demo that's with Golang, right? They are also for Java, for Node.js, then for